This article is mostly a caveat on the issues we have to worry about when it comes to climate actions and what unintended consequences they may have on the deep sea. We have already discussed a little bit about solar engineering and its potential impacts or unintended consequences, which could make it into basically a Frankenstein experiment if we are not sure of what we are doing, and the dangers are real, and there are many caveats about those around as well. So I'll use this paper from Science on an opinion piece called a forum. I think it's called a forum, where they highlight some of the issues, and then I'll add a couple of points that this paper tries to grab from National Academy's report of the US on the caveats for carbon dioxide removal into the ocean, and also solar geoengineering or solar radiation management, also solar dimming, whatever, where we spray aerosols into the stratosphere to reduce the amount of energy coming in. Okay, so here we are looking at the impacts of intervention methods. Light availability changes happens in these places here. Altered food supply in the mesopelagic and some of the epipelagic, and you have animal responses spread throughout, especially in the coastal regions, and you have biogeochemical changes that are possible in the deep ocean as well as in the surface ocean and throughout the water column. So ocean-based climate interventions and their deep sea impacts. Strong connectivity between the surface and deep ocean will transfer impacts through the water column and to the seafloor. Seems obvious, and yet the specific cases have to be made so that large-scale climate interventions can be tracked in terms of their impacts on the ocean, which is already being impacted by ocean acidification. As the CO2 increases, the dissolved CO2 in the ocean increases, so coral shell forming animals begin to suffer. It's not clear how bad it's already gotten, but the heat diffusion has already reached the deeper part of the ocean. Deoxygenation and so on are already being noted because of the human-induced increases in greenhouse gases. Increasing ocean reflectivity. This is going to create light availability and maybe cool the global warming temperatures because of increased albedo, but the negative impacts have to be watched out for as well. Alkalinity addition. So these are some of the experiments being planned in terms of increasing continued uptake of the CO2 by the ocean, and you can see that it will have impacts on biogeochemical changes in the deeper and middle of the ocean. Increasing ocean reflectivity has several ideas which we will not get into here. Ocean and thermal energy conversion, it's seen as a good source of energy because of the constant gradients that are maintained by the dynamics and the circulation. Warmer waters near the surface, colder waters below, so you have gravitational energy, potential energy if you bring up cold water. There are also enhanced productivity at the surface by causing artificial upwelling kind of ideas, so you can see those causing altered food supply as well as biogeochemical impacts. Ocean fertilization, of course, is possible with iron, dissolved iron being, iron being made available at the surface in regions where you have iron limitations, like the high nitrate, high nutrient, low chlorophyll regions in the Eastern Pacific, Southern Ocean, and many other places, maybe even in the Arabian Sea and so on. And there is the potential of greenhouse gas release like N2O, which is more than 200 times as powerful as a greenhouse gas compared to CO2, for example, and has residence times of a couple of centuries, so that's a dangerous experiment as well. Altered vertical migrations are possible because of these food supply changes and biogeochemical changes, and you have also acidification and deoxygenation possibilities because of iron fertilization and increased photosynthesis. The idea, of course, is you want to increase CO2 uptake by photosynthesis, but you want that carbon to sink to the bottom to take it out of the system. to delay global warming essentially, which means deeper ocean is going to experience increased CO2, where its cold temperature, high pressure can dissolve much more CO2, and that could lead to acidification and deoxygenation as well. And you can see the ocean thermal energy conversion that we talked about. Artificial upwelling and ocean fertilization together will cause deep ocean acidification and deoxygenation, and of course will also lead to altered food supply, and dissolved organic carbon can get released because of these changes in biogeochemistry and so on. And there are also ideas of liquid CO2 injection into the deeper ocean, because it has high pressure and cold temperatures, which can hold lot more CO2, like a Coca-Cola can, right? If you have sealed can with at cold temperatures and you pumped CO2 into it, it can stay there, and this is the same idea here. So you have all kinds of circulation changes, and coastal impacts are going to be quite significant as well, which are already happening because of the land use change, fertilizer use, deforestation, urbanization, and so on. And there are ideas of macroalgae cultivation, under ocean visions, geos, and so on, the UN decade of ocean, UN decade of the oceans, I think. Large scale carbon dioxide removal into the ocean are being planned with macroalgae cultivation. So anytime you have artificially increased photosynthesis, you are going to affect the balance that exists, which we have already affected by changing the food web through fisheries, and very high levels of fisheries indeed. So in general, this paper calls for a holistic approach to consider deep sea consequences of all ocean-based climate interventions together. A transdisciplinary, international, and transparent framework is needed, similar to the recommendations made for solar geoengineering research. That's the National Academy's research I'll briefly mention in the next slides. The requirement for rapidly generated quantitative interoperable data across technologies leads us to recommend an integrated, coordinated approach to observation, experimentation, and modeling that includes the early integration of ecological, social, economic, and legal considerations, and engages local communities and traditional knowledge holders. This sounds easy, but actually the modeling of various ecological processes in the ocean is still got a long way to go, together with the physical biases in the models that feed into issues with the ecosystem, biogeochemistry interactions, and feedbacks. Of course, integrating social and economic and legal considerations is even more challenging, but this is kind of a life cycle analysis that eventually becomes important. And co-producing these knowledge and implementing these things with the stakeholders is of course very important. Together, these actions will allow for the design of climate solutions able to do no significant harm and provide evidence-based support to policymakers. Okay, to look at what the solar geoengineering research recommendations included, there were the current status. So engagement, dispersed ad hoc efforts are underway. Some private companies gone and done a small scale experiment. US is funding more research on solar geoengineering, and it's likely it'll be tried at some large scale very soon by somebody. Limited decision maker or public understanding exists there. In terms of research, also dispersed and ad hoc efforts are underway. Limited efforts to coordinate research, which needs to be addressed. Research governance, dispersed ad hoc efforts, again, US doing its own thing, for example. Some potentially relevant national and international laws and regulations have been discussed. IPCC has now considered solar geoengineering in its scenarios as well. Initial program, I have a whole course on geoengineering and many podcasts on the pros and cons of these things, so you can look those up. So initial program design, assessment and program revisions with feedback to knowledge that's gained has to inform decisions. So engagement, research, and governance have to have interactions and feedbacks, and there should always be exit ramps, so that if things look like they're going out of hand or doing harm especially to the global south, then there should be a quick exit ramp to abandon these Frankenstein experiments if they turn out to be so. Three broad categories and 13 research clusters in the proposed research agenda for solar geoengineering has to include context and goals for solar geoengineering research, social dimensions, and impacts and technical dimensions. So including program development pathways, future conditions, integrated decision analysis, and capacity building in terms of training people to do this and deal with the consequences. Social dimensions include public perceptions and engagement. In general, I have talked about public perception elsewhere, and it's kind of all over the place. Some countries not feeling so scared, some countries thinking of it as something dangerous. Political and economic dynamics, governance and ethics, which has to then interact with impacts and technical dimensions in terms of atmospheric processes, climate response, other impacts, monitoring and attribution, technology development and assessment. I won't go into the details here, but the Ocean CDR report from the National Academy schematically represents what we already talked about in terms of taking CO2 out of the ocean and with artificial upwelling, seaweed cultivation, increased algae production, ocean alkalinity enhancement and so on, and storing it either geologically or in liquid form in the deep ocean. So electrochemical carbon dioxide removal is discussed, ocean alkalinity enhancement, I have discussed it elsewhere, seaweed cultivation, ecosystem recoveries, nutrient fertilizations, and artificial upwelling and downwelling. This is being tried as well at some locations like around Hawaii, for example. Whether they are sustainable and can continue to serve as part of the portfolio of climate solutions, net zero, decarbonization, and so on, are yet to be seen in terms of scalability and scaled implementations. But nonetheless, the caveats that go with it: assessment of whether the approach removes atmospheric CO2 in net and the durability of CDR carbon dioxide removal as a primary goal, assessment of intended and unintended environmental impacts beyond CDR, assessment of social and livelihood impacts examining both potential harms and benefits, integration of research on social, legal, regulatory, policy, and economic questions relevant to ocean CDR research, and possible future deployment with the natural science, engineering, and technological aspects. Finally, systematic examination of the biophysical and social interactions, synergies, and tensions between ocean CDR, terrestrial CDR, mitigation, and adaptation as a suite of climate actions have to be considered as well. In terms of recommendations, I won't go into all of them, but common components of an ocean CDR research program. Implementation of the research program in recommendation 1 should include several key common components. That's basically one. The development and adherence to a common research code of conduct that emphasizes transparency and open public data access, verification of carbon sequestration, monitoring for intended and unintended environmental and other impacts, and stakeholder and public engagement, full consideration of and compliance with permitting and other regulatory requirements, co-production of knowledge and design of experiments with communities, indigenous collaborators, and other key stakeholders, promotion of international cooperation in scientific research and issues relating to the governance of ocean CDR research through prioritizing international research collaborations and enhancement of international oversight of projects. We are already colonizing the future in many ways by doing climate change, and then we will try to correct ourselves and create more colonization of the future, and if they have unintended consequences, then we already have to be very careful, because climate change itself is argued to be an unintended consequence of industrial revolution and technological evolution, science progress, and so on, and yet it's not so unintended, in the sense along the way there was plenty of evidence that we were really doing large-scale perturbations to the natural climate system, Earth system, and yet we continued anyways. And we continue still. Capacity building among researchers in the United States and other countries, including fellowships for early career researchers in climate vulnerable communities and underrepresented groups, including from indigenous populations and the global south. So this is a U.S. National Academy's report, so it does focus on the U.S., but the messages are relevant for the global humans. Recommendation 3, finally, Ocean CDR Research Program Priorities. Overarching implementation plan for the next decade adhering to cross-cutting strategy elements in Recommendation 1 and incorporating from its onset the common research components in Recommendation 2, and I won't show table S2 here. Tailored implementation planning for specific ocean CDR approaches focused on reducing critical knowledge gaps by moving sequentially from laboratory scale to pilot scale field experiments as appropriate, with adequate environmental and social risk reduction measures and transparent decision-making processes. Who's going to do these? Who's going to be the monitor, the verifier, and who's going to do the reporting, and how we will ensure that the Wild West approach in the open ocean that works for fisheries also doesn't begin to act on these ocean CDR type of things, where let's say some private company wants to sell ocean CDR as offset for terrestrial emitters and then tries to do things on their own without any supervision, monitoring, verification, reporting, etc. All those are serious concerns. Common framework for intercomparing the viability of ocean CDR approaches with each other and with the other climate response measures, using standard criteria for efficacy, permanence, costs, environmental and social impacts, and governance and social dimensions. So even if we do ocean CDR, how long is it going to stay there? Because if that is seen as a way to continue with business as usual and continue to emit because we keep thinking we are putting it away in the ocean, but it gets released after some time, then we have created a real bigger problem. Research framework including program-wide components for experimental planning and public engagement, monitoring and verification, carbon accounting, and open publicly available accessible data management. Strategy and implementation for engaging and communicating with stakeholders, policymakers, and publics. Research agenda that emphasizes advancing understanding of ocean fertilization, seaweed cultivation, and ocean alkalinity enhancements. Okay, so climate actions which are obviously very necessary and have to happen, mitigation and adaptation, some of them large-scale geoengineering type experiments, climate interventions as we would call them, or geoengineering, will have consequences intended and unintended on the deep sea, and curing the deep sea once if we screw it up is going to be quite impossible. So all these caveats are very critical, so I wanted to include it here, although it's quite brief, but you can follow up the references I have provided here, the 2 Academy reports and the short Policy Forum article from Science. Okay.